Welcome students. In this part I am going to discuss some key points of the chapter chemical kinetics, and also we will see some multiple Let's start with question first. Question is, identify the order of a reaction from the following rate constant unit. And the rate constant is given and its unit is given. It is mole. K rate constant is equal to 5.2 into 10 to the power minus 3 liter mole inverse second inverse. As we know that on finding out the unit of rate constant, this unit liter mole inverse second inverse is the unit for the reaction for the second order type reaction. So the correct answer for this question will be second order. Next question, what is the order of reaction whose rate constant has the same units as the rate of a reaction? Question is saying which order of a reaction, or what is the order of that reaction which has when rate constant has the same unit as that of the rate of a reaction has the units. As we know that rate of a reaction has the unit because rate of a reaction is change in concentration with respect to time. So the unit of rate of constant is mole per liter for the concentration, unit for the concentration, and because rate is per time, so the unit of rate of reaction will be mole per liter by second inverse, or mole liter inverse second inverse will be the unit of rate constant. Here we have to find out what is the order of that reaction which has the same unit of the rate constant or same unit of the value of K, unit of K as that of the rate of a reaction. So the correct answer will be for a zero order reaction, because we know that zero order reactions are independent of the concentration of the reactant. So the value value of the unit of rate constant for zero order reaction is same as the value or the unit of rate of a reaction, that is mole liter inverse second inverse. Question third, At what condition under which a bimolecular reaction is kinetically first order reaction? Under what condition? Which are the conditions under a bimolecular reaction in which two entities or two species combining, two reactants are present? Such reactions are known as bimolecular reaction, and that bimolecular reaction is kinetically a first order reaction. So the correct answer will be a bimolecular reaction becomes first order reaction when one of its reactant is in excess, because as we know that bimolecular reactions are those reactions in which two reactants reacting together and they are forming a product. Suppose there is these are two reactants, reactant A and reactant B, and they are providing up some products. After reaction they are providing some products. Now what will happen? The question is saying under what condition a bimolecular reaction, suppose this is a bimolecular reaction and it acts as first order reaction. A bimolecular reaction can only act as a first order reaction when one of its reactant, either A or B, it is present in excess. Then only a bimolecular reaction act as a first order reaction. So, the next question is order of reaction can be. Options are 0, whole number, fraction, and integer, fraction, or 0. So a order of a reaction, it can be a fraction, it can be an integer, and it can be a 0. So the correct option is option D here. Order of a reaction can be integer, fraction, and 0. Next question. At the beginning, the decrease in the concentration of reactant is. At the starting of the reaction, there is a decrease in the concentration of reactant, because we know that concentration of reactant gets decreases at the starting of the reaction. So at the beginning, the decrease in the concentration of reactants is option A slow, option B rapid, option C moderate, option D none of these. So the correct option for this question will be rapid, because at the starting of the reaction or at the beginning of the reaction, the decrease in the concentration of reactant is very fast, it's very rapid. And you can see when you will plot the graph between concentration versus time, you will see that initially the concentration of reactant will get decreases rapidly. After some time that decrease in the concentration is slow, but initially when you plot the graph between concentration of reactant versus time, so the decrease in concentration of reactant is very fast or rapid. Next question is for the reaction 2A plus B gives 3C plus D. Which of the following does not express the reaction rate? Options are minus D concentration of D by dt, minus half D concentration of A by dt, and option C and option D. So among following, here A and B both are reactant, and we know that when a reaction is forming and the concentration of reactant gets decreases, then the rate of a reaction is denoted by a negative sign for the reactant terms. So these option B and option C both are correct here, because the decrease in the concentration of A, because the stoichiometric coefficient for A is 2, so the rate of a reaction for the decrease in concentration of A is correct here. It is given minus half D concentration of A by dt. Similarly, for the when you will write the rate for the decrease in concentration of B, it will be minus sign, because it is a reactant and the concentration is getting decreases, so it will be minus D concentration of B by dt. So both option B and C are correct here, and you have to select which does not express the rate of the reaction. Now come to the product side. Here C and D, they both are products, and we know that when a reaction is getting completed, the products are formed. So the rate expression or the rate of a reaction for the products, it gives a positive sign. So it should not have a negative sign as they are a product. So here when you will write the rate of a reaction for product C and its stoichiometric coefficient is 3 here, so option D is the correct option because it is a product here, and for product the sign should be positive and stoichiometric coefficient should present in denominator. So 1 by 3 D concentration of C by dt is the correct option. But here you can see for D, for product D, because it is a product and it should not have a negative sign here. It should have positive sign because it is forming after the reaction. As the reactants get collide with each other, it is forming. So for the rate of a reaction of D, it should have this D should have, or the concentration of D should have positive sign, but here in the question it is in option it is given negative sign. So the correct option will be option A, which does not express the correct expression for the reaction rate. Now I have some practice questions for you. So do these questions. Question 1, question 2, question 3 here. Here is question 4. And it is question 5. So total 5 questions are there which you have to practice. So do these questions, and thank you. Keep watching.